Hi everyone, my name is Urvin and today I'm making this video to demonstrate my project report here. So basically, I have made a fully furnished embedded system. Its name is the TermiFlow, and this talking about how I got the idea and what is the purpose of it. So first of all, I would like to discuss there's a small its design principle is like suppose there's a whole wide field, and then you have a small office in which the monitor and the Raspberry Pi, as well as a interactive interface. To control the interactive interface, we will need a mouse. So this is kept in the office side, and this whole embedded system is placed inside the field, and this basically monitors the whole growth of the turmeric throughout his its growth period, because I have used sensors like the pH sensor, the soil moisture, and also the temperature and humidity sensor. As you can see, I have completely demonstrated my project in my class as well. But here you can see a glance that I have an interactive user interface in which I am getting the temperature and humidity readings, and then I have also the soil moisture and pH readings as well. Along with that, I also have some automation controls in which I am using the OpenWeather AI API, which will help us to take decisions. And this makes my project more energy efficient, because suppose if we are expecting a rain in the next half an hour, and we also have a need to deliver the water to the plant to the field. So it will decide whether to turn the respective pump on, because the rain is expected, and hence the open weather API is the uh, main thing that will help in deciding whether to give the water, whether to give what turn on the water pump and give that suitable amount of water or not. So this makes my embedded system more energy efficient, and as well as it real timely monitors the real values of the pH, temperature, and moisture as well. And we also have a manual control as well, because here you can see in my interface, I am having the auto as well as the manual. By switching on to the manual mode, we can completely control the whole system with just a mouse, and it's a really interactive dashboard. I have used hover effects to make it more beautiful, and I have displayed everything in the card format so that it is very easy to use, and it's really interactive because the plain interface and all the graphs and colors are easily analyzed and also visualized as well. And you can control the pump by turning on and off. This is the water pump, and then here is the fertilizer pump. So in this image, you can see that currently my system is working in the auto mode. So talking about the also, there are many things that I would like to talk about, but this would make my video long. But never mind, I will just include them in point. So, the first point I want to discuss, the main point is the robustness. How my system is robustness, because I have made a embedded ready system. Because when we just plug in our Raspberry Pi and just place it and just give a power supply of 5 volt to the Arduino, it will you may see some projects over there when they are just struggling to turn the Raspberry Pi and then turning on their scripts by writing the Python 3 this and that. So here you just need to plug in the Raspberry Pi, give the power, it will just boot up, and it will only take the boot time, and rest all the scripts will be automatically working, and you will exactly see this dashboard over here, because I have used system default functions which will make my scripts. I have used like two I have used three scripts which are already running defaultly by the system automatically whenever the Raspberry Pi turns on. So this one you can see is my GUI script, and then I have the main controller script over which is working in the backend, and then I have another backend script that is saving the data inside the Raspberry Pi, and also I have Among these scripts, there's the backend script is also publishing this data on the Firebase as well, because Firebase provides us various AI tools as well nowadays, which is really easy for us to just analyze those values that we are storing. We can make the graphs as well by using Firebase tools. So I'm also storing it on the cloud as well as offline in the Raspberry Pi as well. So this was my integration. Now talking about how these both systems are connected. This point comes in the system architecture. So my Raspberry Pi and the Arduino is connected via MQTT communication, which is a wireless communication, and MQTT protocol basically. And then if we talk about the another, also I would like to mention the another protocol I have used is the HTTPS, which is the Hypertext Transfer Protocol Secure, which is used to fetch the data from the OpenWeather API and to send, and also to send these, record these readings and the progress by just sending these data to the Firebase. So here the HTTPS is involved, and these are these are the two main protocols that I have used. Now, the another point is that how is my embedded system is following the criteria of fault tolerance. So you may observe that my Raspberry Pi and the Arduino are not physically connected and are placed aside. So what if the Raspberry Pi crashes, and you may think that my system will just fail to operate, and how? So here I have used the logic whenever I am getting any error between the connection between Arduino and my Raspberry Pi. Suppose the MQTT fails, and or just my Raspberry Pi crashes. So what will happen? So I have already defined some particular amount of thresholds, predefined thresholds for the pH, for the temperature, for the humidity as well, for the soil moisture as well. So it will work on the default automation logic, which is just a basic logic, and it will. It is why so because it is used to maintain until the Raspberry Pi is on the good line. But if there's a certain mishandling between the Raspberry Pi and Arduino, then my system just basically works on the predefined threshold so as to preserve those uh, growth, to maintain that growth pattern. So these basic thresholds are necessary for the logic as well, and hence my Arduino just controls the whole system by itself. But the main decision maker is the Raspberry Pi. It needs to be repaired as soon as possible, or if the connection is not there, then it must be recovered as well. So this is my fault tolerance because it makes my Raspberry Pi and my Arduino independent of each other. So basically, this is my fault tolerance, and you may also thought that why I have used the Raspberry Pi and why Arduino, why there is a need to put both of them together, because I already explained in my design principle that there's a small office, and it's a typical design of every farm, that there's a small office and then we have the whole field around. So that's why we are using that Raspberry Pi in the office and then this whole system in the field, that will be continuously taking care of our turmeric growth. So this was my whole system. And also the one more point there was about the threading, how I have used the threading function. So in the threading function, you may see that I'm continuously getting my graph, and then I'm continuously updating my graph and continuously fetching those readings to my Raspberry Pi, and my Raspberry Pi is real-timely updating these values and real-timely controlling those pumps either by manual or by automation logic that I have explained using OpenWeather API. So how this is only possible because of the multi-threading feature. So in the multi-threading feature, There are basically two loops that are being used. One loop is for the MQTT and to get the data. One loop is for the MQTT, and then the other loop is to update the whole GUI of my Raspberry Pi, and hence to update my dashboard and to update those readings. I need two different loops, but in if we write in a code that we say if we run one loop, then the another will never run. That's the logic. So that's why threading is used, which enables us to run two loops at a single time. One is getting the readings and one is updating the dashboard, and basically performing every interactive function that can be used inside the dashboard. So these are the points that are very necessary for my grade policy and for making my embedded ready system. So here's my whole system. You just need to plug in and it's all ready. So thank you for watching.